Now, based on all our design decisions, let's see what the app will look like end to end. Suppose user 1 wants to send a message to user 2. Since our chat app scales to a global audience, we will need a load balancer as our middleware, which will receive the message and forward it further. As response of this request, a message delivery status is sent back to the sender's application. To forward this message to user 2, we need to find his connection object by querying the session manager. The session manager will find the connection from the distributed hash table that we designed earlier. To manage the message delivery status, we can have a dedicated service for it like Status Manager, which may also need to update the hash table with user's connection object. Since we have retrieved the connection now, we can deliver the message to the recipient over it. So we are done, right? No, not really. If user 2 closes the app and reopens it, he will not see the message anymore since we didn't persist it in the storage. So let's figure that out. Once we have received the session from Session Manager, we forward it to our main chat server. There could be some security or privacy features our app provides. We don't need to deep dive into them, but we can have a data privacy server to take care of it. Let's consider a simple private chat message for now. The private message will be sent to a service that is dedicated to handling private chats. Let's simply call it Private Chat Service. As we decided in our database design, text messages will be persisted in HBase. Since we are also supporting images, if a message is image, we can perhaps use a dedicated service to handle images, such as an image processing service. This service will internally use blob storage to persist images. Similar to private chat service, we can use a group chat service to handle operations around the group chat. Now, if we really think about it, group chats are just an extended version of private chats. So perhaps we can reuse the implementation of private chats to support group chats. The flow we have designed so far is when both the sender and receiver are online. However, if the receiver is offline, we will need to notify him the message. To do this, we can push him a notification from the chat service. We can again use a dedicated notification service to handle operations around notifications. Now, let's think if there is any scope of optimization in this design. Can we leverage a caching mechanism to speed up the chat retrieval? When the receiver is offline and receives a notification of a message, they might open the app right away. So, to optimize retrieval at this point, perhaps we can use a cache service to handle cache mechanism centrally. Internally, we can leverage a cache store like Redis perhaps. Our app might also want to support additional features like analytics perhaps. To support this, we can asynchronously publish a Kafka event. These events can further be consumed by further devices like analytics perhaps. So this looks quite good enough for the scope of an interview. If you have some other use cases in mind, you can surely pitch them to the interviewer.